All right, 7.6, the last section in Chapter 7 here is called linear programming. And this is where our inequalities are leading into the real-world applications, okay? So why do we do inequalities? Well, when you get into the business world especially, there's always this challenge of maximizing profits, minimizing costs, and trying to do the best with the materials you're able to get. So what we have is we start with an objective function, and this is an algebraic expression in two or more variables describing a quantity that can be maximized or minimized. We often started out with z equals something. So when you see the z equations, that's usually your objective function. Sometimes that is maybe your profit. So maybe instead of z, it's a p for profit, or maybe it's a c, so it's your cost. There's no great systems of equations when you get in the business world where you can solve it and say, this is the solution. It's more about how can we use our resources to the best of our abilities, and where can we go, and how could we do this in the best way possible. So you have these constraints though, because sometimes you're limited maybe to the materials you can get, or maybe you're limited by the weight of something. Maybe you're limited by you have to make so many of this or something. Maybe there's a government regulation. So there's constraints, and these are expressed as a linear inequality. Okay, and that's going to help us kind of say, now, where do we have to stay within to be able to do this project? So as we solve a linear programming problem, you're going to see z be your objective function, okay? And as we do these, some of them, and in fact, on your test or quiz for this chapter, I might give you just a kind of a story problem and say, what would be your objective function be? What are we looking to do here? Okay, and we'll show you an example in the notes. And then you get these constraints as well. So once you get your constraints, which are usually your max and mins and such, you're going to graph this system of inequalities that you're given. That's by your constraints, okay? We don't graph the objective function. We only graph the constraint inequalities. Then we find the values of the objective function at each corner or vertex. We go and find the vertices of that overlapping area from all of our inequalities. And at each vertex, that can become a max or min point for our objective function. So we're going to go and find each vertex, and then we're going to find out which one has the best value going off of our objective function. Okay, so instead of starting us out with one great big problem and doing everything, I'm going to start off with, let's say we've already found all of our graphing, we already have everything. Let's just work on the last step, which is what's our max or min point, okay? So on this first example, they give us an objective function, okay? They already give it to us. Either we come up with it with information given to us, or it's given to us from the beginning. This time it's given to us. They've already graphed all their inequalities, all their shading, and not only did they get rid of all the shading and stuff, they left us with just the overlapping area. That's all we see right here, okay? So what we see is there was, if you look at it, there was 1, 2, 3, 4, 5 different constraints that were graphed and shaded, and their overlapping area is just this figure right here, okay? So what they did is found the ordered pairs, or the corners of all of those corners, vertices, whatever you want to call them right now, of that overlapping region. And we're going to now use them with our objective function to see where is my max or min value for this, okay? So what we're going to do is we're going to just start listing all of our ordered pairs. I like to start in the bottom left corner. It's just a habit of mine, and go around clockwise. So I have a 3, 2, 4, 10, 5, 12, 8, 6, and 7, 4. That's all my ordered pairs. So I'm now going to test them with this function of z equals 3x plus 2y to see what their values are, if that kind of makes sense. So I'm going to plug in the 3 times the 3 plus my 2 times my 2y. Well, 3 times 3 is 9. 2 times 2 is 4. 9 plus 4, that gives me a 13. Okay? And let's try it with the 4. 10. So 3 times my x of 4. 2 times my y of 10. That's a 12 plus a 20 makes 22. No, how about 32, if I could add correctly. All right, on my next one, I have a 3 times a 5, which is 15, 2 times 12, which is 24, 15 and 24 make 39. I take my 3 times my x of 8, which is 24, 2 times my y of 6, which is 12, and I add those together and I get 36. And finally, my last vertice, ordered pair, the corner of my overlapping area, 3 times my x of 7 is 21, 2 times my y of 8 is 8, 21 and 8 makes 29. Okay, so we've used our corner points, if you want to call them that, to see, well, where would my minimum or where would my maximum come from, okay? So I just look at my values now. Obviously, my maximum value on this whole list is 39. So that means, and I'm putting a scenario to this objective function. If I make 3 of product X and 2 of product Y, I'm going to maximize it out to $39. Something to that effect, if that kind of makes sense. So this is my max, okay? And then again, when I look at all my values, this is my min, okay? Not knowing what I'm finding here, maybe I was going for the cost of how much it costs to produce these. So if I make 3 of product X and 2 of product Y, I do the minimum cost, okay? I don't know where this is going, but sometimes we need the max and sometimes we need the min, depending on what we're trying to do. So we use these corner points to get there. Okay. Let's go to the next example, right, on the next page, and see kind of here. This time, we're going to do the graphing, and they gave us the objective function. And it does tell us on this time that we are looking for the max value when we get done, okay? So my objective function, we do not graph, okay? You do not graph the objective function. That is to figure out later your max or min points. So do not try to graph an objective function. We graph all of our constraints, and we find and we're looking for those overlapping areas. Okay. This first restraint is sometimes like an unspoken restraint, but sometimes we put it in print as well. When we're talking manufacturing, you can't produce negative of anything. So because of that, your X and your Y are always positive, okay? So that's basically saying all my X's need to start at 0 and go here. All my Y's need to start at 0 and go here. And we're not going in any other quadrant to graph or anything else because I can't make negative of a product, okay? So basically with that line right there where X is greater than or equal to 0, Y is greater than or equal to 0, it basically means stay in quadrant 1, right? And that's all we have to do. You'll notice I didn't even give you a graph that could graph into the other quadrants. So sometimes that constraint is almost an unspoken one as well. It might not be shown, but we need to remember we can't make negative of a product. Okay, second one here. 2x plus 3y is greater than or equal to 12. Set up perfectly for intercepts. So if I plug in 0 for x, I get 4 for y. If I plug in 0 for y, I get 6 for x. That gives me some points to go. 0, 4. That's this point up here, 6, 0. Okay. I say this, and this is going to be a do as I say, not as I do. The more you can use straight edges, the better you are on these kind of problems. We need the straightest line segments possible, okay? And of course, being on my device here, I'm not going to be able to do a real nice one, but I'm going to have to work with it otherwise because of this. Okay, so I graph it. But what's super important is knowing where I'm shading. Okay, so I'm going to choose 0, 0 and plug it in. If I plug in 0, 0, I'm going to get 0 plus 0, which is 0 is less than or equal to 12. Yes, I want to graph over 0, 0. So I'm shading down below. Okay, so I'm kind of in this triangle right here. Okay, second one here. Just for ease, it's real easy to get this in slope-intercept form. I'm going to subtract that x. All right, so I want to go to positive 3, and I want to drop down 1 over 1 for my slope. Okay, so here's my second line. If I plug in 0, 0, 0 is greater than or equal to 3. That is false. I don't want to graph over 0, 0, so I'm graphing this direction. I could keep going, but really I just want to know where I'm overlapping. So I am overlapping in this section right here, okay? So what I really need to focus on now is where are my vertices, my corner points? Where's the overlap? So over here, I have an overlap, and that point is up 3, so 0, 3. Right above it, I have another one at 0, 4. Another corner point over here, that was that point 6, 0. And we have this other corner point 1, 2, 3, so 3, 0. So I have 4 corner points right now, 0, 3, 0, 4, 6, 0, and 3, 0. Okay, this is where I now take those as my border points and put them into my objective function. So I always say I like to start at the bottom, right? 3, 0, I'm going around clockwise, 0, 3, 0, 4. It's important that we use all of them, okay? 6, 0. And I'm working with my objective function, which was z equals 4x plus y. So 4 times my x, which is 3, plus my y is 0, gives me 12. Plug in my 0, 3. So 4 times the 0 plus 3. So 0 plus 3 is just 3. 0, 4. So I get 4 times 0, which is 0, plus 4, which is 4. And finally, 4 times my 6 plus 0, that's 24, plus 0 is 24. Okay, so I am looking for the maximum value. So it looks like maximum value here. It looks like I should make 6 of product X and 0 of product Y. Okay, whatever that is. So when it asks for determine the maximum value of the objective function, it would be 24. The value is 24, and that's by making 6 of X and 0 of Y. Okay. Next step, I'm taking a step up. We're going to do everything, objective function, constraints, everything. We're going to put this more in a real-world problem, okay? So in example 3, and really this is where we're going with all of this, is how can we apply it to the real world, right? So in example 3, food and clothing are shipped to survivors of a natural disaster. Each carton of food will feed 12 people, while each carton of clothing will help 5 people, okay? That right there is my objective function. It's giving me some values for what we can do. So let me write an objective function. Z equals, okay. By the way, let's go food. Let's call X my food and Y my clothing. Okay, I need to establish that so I can go. So each food helps 12 people, so 12 times each food, and each clothing helps 5 people, so 5 times each Y. That's my objective function given what they told me I can get, okay? The value of what this will do. So that's my objective function. Okay. Now, then we have our constraints. The commercial carriers transporting the food and clothing are bound by these following constraints. The total weight per carrier cannot exceed 19,000 pounds. I guess I skipped a sentence up there, didn't I? The total volume must be less than 8,000 cubic feet. Okay. How many cartons of food and clothing should be sent with each plane shipment to maximize the number of people who can be helped? So here's that objective, is how many people can we help? That's why we wrote this objective function for the people we can help. Remember, we're not going to graph that. That's what we're going to figure out at the end. Okay, back up here since I skipped this sentence. Each 20 cubic feet of box of food weighs 50 pounds, and each 10 cubic box of clothing weighs 20 pounds. Okay, total weight cannot exceed 19,000 pounds. So a food box is 50 pounds. So 50 for a food box. And each clothing box weighs 20 pounds. Okay, so these two weights cannot exceed 19,000 pounds. So that needs to be less than or equal to 19,000. Okay. Total volume must be less than 8,000. So volume this time, that's my how much space it takes up. So a 20 cubic box for food, 20 for food, and this time 10 for clothing. They must be less than, so they have to be less than 8,000. Okay, so there's my constraints based on what the airplane can carry. Don't forget, again, we can't take negative of anything, so X should be greater than or equal to 0, Y should be greater than or equal to 0. Remember, we could find out that maybe we should only take food, or maybe we should only take clothing. So that's kind of what we're trying to figure out here. Okay, our constraints are what we're going to graph to find our corner points. So let's see if we can do the best job we can here in graphing this. Okay, The first two just mean we're staying within our quadrant, right? So I'm not going to shade because that's just going to get messy with my x is greater than 0 and my y is greater than 0. For my next one, 50x plus 20y is less than or equal to 19,000. Okay. If I find my corner point, or my intercepts, right? If I plug in 0 for x, divide 19,000 by 20,000, I'm going to get 950. If I plug in 0 for y and divide 19,000 by 50, I get 380. Okay. One thing I can say for sure as I look at this right now is, of course, my points are huge, which means I'm going to need to scale my graph. But this is real world, big numbers, things like that, right? On my second equation, if I do my intercepts, plug in 0 for x, I'm going to get 800 for y, right? Or 800. And if I plug in 0 for x, I'm going to get 400. Or 0 for y, I'm going to get 400 for x. Okay. So my y's go as high as 950. My x's go as far as 400. I think I'm just going to go by hundreds, okay? So I start at 0, 0, and I think I'm going to make, let's see, I have enough room. Every 2 lines, let's make 100. So 100, go up 2 lines, go to 200, up 2 lines, go to 300, up 2 lines, go to 400, 500, 600, 700, 800, 900, 1,000. Okay, so every 2 lines, well, every line's like a 50, right? So going across the same thing, we're going to do 100 on the second line. Make sure I'm on the right line. 200, 2 lines, 300, 2 lines, 400, 500. Of course, this one's not going to go as far. We can already see by our ordered pairs that we're not going to get as high, but we can still label. Okay. All right, so first order pair 0 and 950. That is this point right there. Okay, and then 380. So we're going to estimate just a bit here. Again, the straightest line possible would be best. Okay, there's the first one. If I plug in 0, 0, is 0 less than 19,000? Yes, so I'm underneath this line. And again, I'm not going to go into the other quadrants because I know that I have to stay in the first quadrant. Second line goes to 0, 800, so we're a little bit lower, and to 400. Okay, the last one was at 380, right? So we are going a little bit farther over. Okay, and if I plug in 0 and 0 is 0 less than 8,000, yes, this one also shades underneath. Okay, so where is my overlap? Okay, this is where we have to be careful. Okay, so my overlap is, oops, that was on my highlighter. It's all in this corner. Okay, but it doesn't go quite as far as that blue line everywhere, and not as quite as far over as the red line. Okay, so let's see if we can establish some corners here. Let me get a different color. Okay, I definitely have 0, 0. I go up as far as this, is it the 0, 800? I think that's definitely one of my points. Okay, and I only go as far over as the blue line, which was the 380, 0, right? I don't want to look like I have a decimal. 380, 0. Okay. Now, somewhere over here, these two meet, and that's the other corner. Okay. I can tell you right now, with the scaling, with my sloppy lines, I am not going to be able to accurately find that point just on the graph itself. Where do those two lines meet? It's a systems of equations, right? So they meet where those two systems have a point of solution. Okay, I'm going to give you a hint. I'm going to multiply this one by -2. I'm going to leave the top one the same, 50x plus 20y. Don't worry about the inequality signs right now. As we solve this system, it's going to be fine. I get -40x minus 20y is less than, don't worry about, again, don't worry about the inequality signs. Negative 16,000. Okay. That'll give me 10x. My y's cancel. Don't worry about the sign. 3,000 divided by 10. My x is going to be 300. Okay. When I plug in 300, oh, where me and these extra parentheses or commas or whatever. There we go. 300. I'm going to use it in the bottom equation. So 200 times 300, 20 times 300. Less than 8,000. That's 6,000 plus 10y is less than 8,000. Subtract my 6,000, 10y is less than 2,000, and my y must be 200. Okay, so that point right there must be 300, 200. It's where those two intersect, okay? So that's a border point for me. So I have my 4 border points, 0, 0, 0, 800, 300, 200, and 380, 0. Okay, let's see if we can squeeze in our objective function somewhere. Okay, let me put this way over here, see if I can squeeze this in. Okay. So the points I want to check are 0, 0, 0, 800, 300, 200, and 380, 0. And I'm trying to figure out what's the maximum help I can give these people, right, with trying to send these boxes on this airplane. Okay. I'm plugging into, what was my equation up here? 12x plus 5y. All right, 12x plus 5y. That's my objective function, right? Okay, so 12 times 0 plus 5 times 0. We're going to save a lot of gas on that airplane, but guess what? We're helping nobody. 0. If I do 0 and 800, so 12 times 0, so no food, but 800 boxes of clothing would help 4,000 people. Okay. If I do the 300 and 200, so 12 times 300, it's 3,600, plus the 5 times 200, that's another 1,000. I can help 4,600 people with that one. Or in the last one, 12 times 380, plus 5 times 0, so 12 times 380, 4,560. Okay, so what's the maximum number of people I can help? Right here. I can help 4,600 people if I send 300 boxes of clothing and 200 boxes. No, I'm sorry, I flipped that around. Max would be 300 boxes of food, right? That was my X, and 200 boxes of clothing. I can help 4,600 people, okay? This is a linear programming type of problem, and that helps me maximize the help I could give with this given constraints, okay? It really gives us value to what we're learning here as we can see that we can put it into these real world. I want you to practice these because they're not hard necessarily, but you kind of have to wrap your mind around them. And it's good to practice just writing an objective function and writing some constraints based on what you know. So homework, page 795, 3 through 18 by 3s, okay? That's not very many questions, like 6 of them, okay? But they might take you half a page or more each. Please practice. Let me know if you have questions.